everyone, welcome to this lecture. In this lecture, I'm going to discuss very simple trick to draw and find total number of isomers for alkanes. Now remember, in order to write down the isomers of alkanes, it takes a lot of time. But I'm going to share a super trick to find out the isomers within a short time. Okay, so let's start with the topic. Now suppose if I take the first example of methane. Now I know the structure of methane is CH4. So for methane, there is no other structural form I can write down. So it does not have any isomer. Okay, there is not any other structure I can write down. So it cannot change the structure. The second one is, if I write down the structure of ethane, ethane is CH3 bond CH3. If I write down the other way also, I'm going to get the same structure. So no isomer for methane as well as no isomer for ethane. Okay. Talking about now propane. If I write down the structure of propane, the structure of propane is CH3, CH2, CH3. Again, there is what? Even if I change the structure, I'm going to get the same compound, right? The same thing. So again, we cannot change the structure. So no isomer in case of propane. But if I look into butane, okay, let us write down the structure of butane. So butane is CH3, CH2, CH2, and CH3. So the same structure, I can also write it down in this way, CH3 and CH3. So if I look into both the structure, there are total 4 carbon atoms, isn't it? So I call these two are what? They are isomers of each other. And how many isomers are possible, students? For butane, looking at the structure, it is total 2 isomers. Okay. Now, same way, if I draw the structure of a pentane, okay, if I draw the structure of a pentane and then the isomers of pentane. So I'm going to get CH3, CH2, 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 CH3. So see, it takes a lot of time, right? So it is time consuming. But what if I tell you that there is a super trick to find out the isomers, okay, within a fraction of seconds. So first, let us try to understand the concept and then we will try to find out the number of isomers for pentane. Clear? Now, the simple formula is, we are going to use the formula 2n minus 4 plus 1. This is the simple formula. Okay. Now, what do you mean by n? N is basically the number of carbon atoms, right? Let us take now the example of butane. Let us take the example of butane. Now, in butane, I have 4 carbon atoms. Let us try to substitute here. So, 2, what is formula? If I put 2, then n is the number of carbon atoms. And how many carbon atoms do we have? It is 4, 4 minus 4, and then plus 1 we have. 4 minus 4 is 0. And anything raised to 0 is 1. So 1 plus 1, it gives me 2. Right? So how many isomers are possible for butane? Just now we have written the structures, 2 isomers. So see, you can see from this formula also, we are getting the same answer, but very fast. Okay? Without solving without drawing the structures also, we are able to find out the isomers. Clear? Same way now, let us have a look on the pentane. Now, how many isomers are possible in pentane? Now, in pentane, the number of carbon atoms is 5 carbon, right? So, I'm going to simply put here the value of n is 5. 5 minus 4 is 1. 2 raised to 1 is 2. So, 2 plus 1 gives me 3. So, how many isomers are possible for pentane? It is 3. Clear? So, likewise, you can solve for the alkanes using the same formula. But remember, if you're using this formula, so this formula, it is applicable only till hectane. Okay, so that means I can find out butane, pentane, hexane, and for heptane. Now, what about the other alkanes, the higher alkanes, that is octane, nonane, and decane? Now, there is one more formula for that. Quickly, we will have a look on it. Now, quickly, we will have a look on the value of n as well as the total isomers. Okay. Now, over here, till 7, we are going to use the same formula as I said. The formula is what? 2 raised to n minus 4 plus 1. Okay. Let us take one more. That is for 7. So, for 7, it is what? 2. 7 minus 4 plus 1. 2 raised to 3 plus 1. And this will be 8 plus 1, which gives me 9. So, total 9 isomers are possible for heptane. Let us have a look on now octane. Now, for octane, I'm going to use different formula. The formula is over here 2 raised to n minus 4. This will remain same. Instead of 1, we are going to now keep on adding. This will be 2 raised to n minus 4 plus 2. So quickly we are going to substitute. Now n value is, in this case, it is 8. 8 minus 4 plus 2. This will give me 2 raised to 4 plus 2. 4 is how much? It is 16 plus 2. And then we get the value as 18. Clear? Similarly, over here, it is 2 raised to n minus 4 plus 3. And then in this case, again the same way, 9 minus 4 plus 3, this will give me 2 raised to 5 plus 3, and then the final answer is 35. Clear? So likewise, we can simply derive the formula in order to find out the total isomers of alkane. Clear? Now coming to the last one, the number of carbon, what you can do is simply you can add up all the numbers, okay, all the above numbers, that is 1 plus 1 plus 1 plus 2 plus 3 plus 5, 9, 18, 35. If you sum up all the numbers, I'm going to get the answer as a 75. Clear? So this is how you are going to find out for decane. Now there is one more formula for decane we can use. The formula is 2 raised to n minus 4. This is going to remain same, plus 1. Okay, this is also same like the for the first one we have used. Okay, 2 raised to n minus 4 plus 1, and then you are going to add this n. Okay, we are going to add the n value. So this will be 10 minus 4 is 6 plus 1 plus 10. So what is the answer over here? 2 raised to 6 plus 11. So 2 raised to 6 is how much? It is 64, and then plus 7, I'm going to get the value as 75. Is that clear? Okay. So likewise, after 10, you can use this formula. But I think till 10, you should know all the isomers. And then based on the formula, you can quickly find out the answer. Okay. Quickly, now we are going to start solving few questions. Take out your notebook and copy down the question. Write down the question. The first question is, the question now. The question is, find the total possible number of isomers for heptane, octane, and nonane. So simply you are going to use what? The formula. Already I have shared the formula. The formula of till heptane is 2 raised to n minus 4 plus 1. Then for octane it is 2 raised to n minus 4 plus 2. And for nonane it is 2 raised to n minus 4 plus 3. Use this formula and find out the isomers. Write down the answer in the comment box and do not forget to share your answers, as well as if you are facing any difficulty, do not hesitate to write down in the comment box. I'll definitely help you out. Thank you.